All right, so today I thought I'd show the saltwater etching process. We've been using this for a while. I know other metalsmiths, Arthur Hash is actually who I learned this from. I have read a few things about using saltwater or a brine solution. Some people advise against it. I know a ton of smiths that are using this, so I'll kind of leave it up to you. I'll try to put some information, some handouts, make those available, so if you've got questions about what it is I'm referring to about cautions with using a brine solution, you can read about that. Some people are using copper sulfate instead of salt water as their etching solution, but both of these processes are pretty similar in that you're using electrical current that's generated by, in this case, by a rectifier to be able to remove copper from your etching plate. And so what we're going to wind up doing is we're going to be using an etching plate that, pull this in frame here. So this is an etching plate we've been using. It's kind of gross and kind of dirty. Normally I'll throw this in a pickle and pickle this before we use it. And that way it's like super clean. And then we're going to put that on one side of a container, and then we're going to hang this in the other side of the container, making sure they don't touch. That's very, very important. But this will have a positive connection, and this will have a negative connection. And what will happen is that the salt water will become a carrier to kind of start pulling away material from this plate onto this plate. Now it's important when you're selecting this plate that it have at least equal to or more surface area that's exposed to the plate you're etching. So that's why our plate is quite large. If I use this plate, it probably would be pretty close, but I want to use a larger plate because you want more surface area than you're trying to etch available on this side. All right. So the thing that we need to do is we need to prepare our plate for making that electrical connection. So what we typically do in our studio, you could use either a piece of wire or a piece of strip as a connector. So we need to make sure and attach this. Now it's important that this be metal to metal connector. We could even come in and sand away a little bit of that heat patina and do the same thing on this sheet if we want to. I know we'll get a good connection because we've got such a large section that we'll be touching. So I'm going to lay this down, and then we're going to use packing tape as a resist on the back side, but also as a connector. Let's see, we need to switch out our roll here. Should have done this ahead of time. Find my end. There it is. Got a demo on how to change out your tape. If I can find my end. Sorry for the delay on that one. Alright, so now I'm just going to take a little bit of tape and tape down that strap, making sure that I'm sealing up along the edge. And I'm just using a small amount of tape to begin with just to get this placed where I want it. And then I'm going to come back and I'm going to cover that entire plate. Now, in this case, using a rectifier and electro etching, usually get a pretty straight line etch directly across from the plate that you're using. So normally, you're not going to get etching action on the back side, but you might get a little bit of residual etching along that connector where that plate is if you're not careful. So I usually try to seal this up nice and tight, and then I'll even usually put a little bit of tape over the plate where it would be exposed. Actually, not my plate, but my strap. Right, this will keep this from etching. A lot of students forget this. They this is down in the saltwater solution, and so it starts to eat away and deteriorates fairly quickly if it's thin or narrow, especially if it's a wire. And so I make sure to go ahead and cover that, because I don't want that to etch if possible, but I do want this to be exposed so I can hook on my electrical lead to that, so I'm making metal contact. So I usually just wind up bending this over a little bit, and then this is going to set in the solution, and this is going to set in the solution. Again, positive, negative to this, and then we're ready to etch. Now, our solution that we're using is basically just water, and I'm going to stir this up. This has copper that's settled out. This will happen over time. The copper that's copper particles that have been etched will turn your solution kind of an orange color, right? And so we're going to stir this up, and we're also going to stir up the salt. The salt will start to settle. Now, the way we created this solution was I boiled some water and filled up my container with water. In this case, we're just using a Rubbermaid container. It doesn't need to be glass. And I've boiled some water, I pour it in, and then I start adding salt, just regular table salt. We'll just add that until we start to see that the salt is mixing and dissolving in, but there will reach a point where the solution will become super saturated, and the salt will no longer be dissolving. So you'll hear it. It'll sound kind of gritty in the solution, and then you add a little bit more past that point, and then you've got this super saturated salt water solution. And again, we've been using this for a while. In a classroom setting, sometimes we'll even drain off the copper particles at the bottom. When that separates and settles out overnight, I can drain off the good water, the salt water, and then pull out some of the excess copper, because you don't want it to get sludgy at the bottom. If it gets sludgy, the danger is if this is touching at the bottom and this is touching the bottom, you're actually creating a direct wired connection between those two, and it'll actually overheat or melt your wires, or burn up your rectifier, or potentially start a fire. So you need to be really, really cautious, making sure that this is not getting too sludgy at the bottom from copper particles. If it's just salt, you're okay, but you do want to stir this every time you get ready to use it. You stir it up really well, and then you're good to go. So we're going to insert this again. I want to make sure that my entire plate is down in below the water liquid line, and I'm going to put this in. I will see how this goes. I should have cleaned this plate, but for the sake of the demo, we'll go ahead and hook up. So I'm going to use positive connection here to this, negative to my plate. And then we're using, like I said earlier, a rectifier. We use this for electroplating and for anodizing. This is kind of a big beast. They make smaller ones. You can look up Caswell Plating sells smaller rectifiers that would be suitable for this. Amazon also sells those, so look into that. They make small digital ones now. I just like this one. This has a lot of power. We don't need that much power though for this. So you'll notice that when I start my rectifier, I always have it in the down position so that I'm not feeding any current in. I'm going to flip the switch on. This will light up, and then I'm going to start feeding it a certain number of volts. Now what I'm looking here, I usually etch around 4.5 volts, something like that. So I'm dialing this up until I start to be about 4.5. Now if I've got a good connection, eventually we'll start to see a little bit of fizzing that comes off of this main plate, this bigger plate, larger plate. You'll see a little bit of fizzing occur. Let's see if I can turn this carefully, and so you can kind of see. So and it usually takes a minute or two for it to start forming that fizzing action. Now you want to do this in a well-ventilated area. This will give off hydrogen gas, so we're hooked up here. We've got ventilation above us, and it's drawing out that hydrogen gas. You would not want to do this near your torch setup, obviously. So make sure you do this in a well-ventilated area. I usually tell my students, step away from it. Don't mess with your connections. Once your rectifier's on, we are working with water, we are working with electricity, so you need to use caution at all times. Some people wear rubber gloves if they are going to touch this. Again, I just get to where I don't touch it. If it's like on, I make sure I don't touch that plate at all. Now I'm going to stop for just a second. I'm going to dial this down and just show you. I can tell if I'm getting etching action. You'll be able to tell by the way this plate looks. So I've turned everything off. Now it's safe to touch. I can unhook this, and you'll notice this looks real peachy here at the top. This is where the water line was. So I can tell I'm getting good etching action. Even though I'm not getting a ton of fizzing off that plate, we know we're etching, okay? So I'm going to hook that back up. Just wanted to show you what that looked like. You can always check it to make sure that it's working. So then we'll flip on our rectifier and we'll dial this up. There we go. So now we're back etching. Now a lot of times we'll set a timer. And that timer, I usually do like 20-minute increments, okay? So I can set that timer, and then this will go off, and then I can bring it back. I can come back over after it's the 20 minutes is up, turn my rectifier down, flip off the switch, unhook my connection, and check my depth, my etching depth. And if I'm happy with it, we're good. That's it. We peel off our resist, and then we remove the front resist, and we're good to go. If we want to go in for longer, we just put it back in, click on our rectifier, set it for another 20 minutes. So this is going to vary the length of time on the surface area that you're etching. It's going to vary in terms of the saturation of your salt water solution. So there's a few different variables. So I can't give you a set time and say, oh, you're going to get this amount of etch depth at this much time. Just going to vary from piece to piece. And as your solution ages, that's going to also change how quickly it etches. Usually when you have a new solution, it etches quite quickly. So I've wound up etching things in 20 minutes, and it's really a nice etch. And you usually get a pretty clean etch by being a direct line etch. You get very little undercutting that I found. Most resists hold up really well. Obviously, salt water is a fairly benign, solution, so you can get some really nice etches out of this. And it's a little quicker than using ferric chloride, unless maybe you were using a spray etching setup with ferric chloride. So again, this is kind of our main setup, our main etching setup. It's good for our beginning students. They don't make a huge mess with it. We can etch copper and we can etch brass with this. And I still use a copper plate even when I'm etching brass. I will use even a copper connector with brass for my connecting strap, but brass will etch just fine. We don't do nickel. We've not done nickel with this. I still use ferric chloride for nickel. I just think ferric gives you a really nice etch with nickel that I particularly like. You won't get the texture that you sometimes get from ferric chloride when you float in a ferric chloride solution. So if you like that texture that you get, that kind of swirl texture, you won't necessarily get that from this, but it's still a very clean etch. So we'll try to pull you back here at the end of the video and try to show you what this etch looks like here in just a little bit. And so yeah, hope that was helpful. All right, so we've been etching for quite a while, so we're just going to dial this down, turn off our rectifier. Now we're safe to touch. We're going to unhook our clip, and we'll lift this out. You can see we've got a really clean etch, with a decent depth there. All right, now a couple things about this solution. Obviously we're in a university setting, so when our solution, as it gets like a lot of copper particles in here, a lot of times I'll drain off the liquid that sits on the top, and then I just dispose of the copper sediment and salt sediment through our hazardous waste material area on campus. A lot of folks might not have that benefit, right? So I would imagine, letting that dry out, that sediment dry out and fully dry, and it'd probably be fine to dispose of it in a manner where it's a dry kind of crystalline structure, crystalline material, versus liquid that you obviously don't want to pour into a water system. I still would be very cautious about trying to find out if you can have that maybe taken to refinery so it can actually be refined as a copper material. Probably safer, making sure that it doesn't re-wet in a landfill or something like that and get into a water system. But you do want to check with your probably local area waste management area to kind of find out what would be best as far as disposing of that. Some of you might be curious about etching silver in this manner. You can etch silver in this manner. I've mainly seen folks using copper sulfate as that solution, but they don't mix them. They don't mix copper with their sterling silver etching solution. So having a separate copper sulfate etching solution that you're etching silver with would be advisable. So keep that in mind if you're thinking about using this with silver. When it comes to removing this, we're just going to peel off our strap, and we can just peel off our tape with that. You'll have some sticky residue left on that back of that plate. This is completely reusable. You can see we didn't damage this at all since we taped this up. There was nothing that was eaten away on this, so this can be reused with the next piece that we decide to etch. We'll just peel that off, and we can re-straighten that. Dispose of our tape, and then I can rinse this off in the sink, and then the resist will still be there. There's a couple different ways that it would take to remove this. You could obviously sand this off if you want to remove the resist. You could also use acetone or fingernail polish remover, or you could actually heat and burn this off. So any of those three methods would work just fine. And then once we've removed that resist, we could clean this piece of copper. We could pickle it if we wanted to, but we could clean it with pumice, and then we could come back and apply liver sulfur patina to darken the dark areas. Again, though, the image would read different, right, if I darken these back areas. So ideally, I probably should have reversed that resist to begin with to make it read properly when we liver sulfur it. But I think this still gives you an idea of the kind of the depth of the line. I'll try to show that. Is that showing up? So you can kind of see the detail in the fine line, and you get very, the resist holds up well. You don't get undercutting. Nice deep etch. So I'm just going to rinse that so you can get a better look at it. I'm just trying to show it at the angle there so you can kind of see how deep. Nice clean etch though, right? And you can see all that, webbing. We got a little breakdown of our resist right in here where that toner started to lift a little bit. That could be an adhesion problem or just a small detail, I'm not sure. We're still holding up things like this. So. I think we'll leave it at that. So yeah, if you've got any questions, do feel free to reach out. Let me know if you're curious about how that resist works or that process, or etching other materials. So don't hesitate to reach out if you've got any questions. Thanks.